Hey guys, welcome back to Mechanical PE Exam Prep. If you'd like to be notified when I post new videos, go ahead and subscribe to this channel if you haven't already. And if you want to get the basics down before solving lots of problems, take my Udemy course, HVAC and Refrigeration Fundamentals. In less than 5 hours, you'll review all the major topics you need for the PE exam. By the end, you'll actually be excited to start studying. Okay, so next let's jump to the last question, which is what's the capacity of the air conditioner? In order to figure that out, we have to take two things into consideration. We have to consider the heat load in the room, which we've already figured out. We know the total heat load. It includes all the internal and external, so we said that was 298,000 BTUs per hour. But we also have to consider this outside air. Some of that cooling in the room is happening, but it's being wasted, and this is why outside air is a bit painful when it comes to operating efficiently, because you have this air that's 75 degrees. It's pretty useful. You could recirculate it and just cool it down a little, especially if it's a hot day. But unfortunately, you have to exhaust it and bring in this outside air, which is 90 degrees and has to be cooled a lot more. So be that as it may, we have to consider the cooling required for the outside air, but we know the outside air conditions. We know it's 90 degrees and 70 wet bulb, and we know the volume, and we know what temperature and humidity it needs to get to. It needs to be reduced to the conditions inside the room. And we have plenty of information about what those conditions are. So we can find the enthalpy of the outside air that's entering and the enthalpy of the air in the room and do an m dot delta H, which will give us the rate of heat transfer for that component. So let's write some of this out. So first of all, we have those room conditions, 75 degrees and 50% humidity. We can look that up on the psychrometric chart. 28.2 BTUs per pound is the enthalpy in the room. And I put that into a psychrometric calculator because I like to be precise, but you should be very comfortable looking that up on the psychrometric chart. And then the enthalpy of the outside air is 33.9 BTU per pound. That's the 90 degree and 70 degree wet bulb. So let's find the heat load that's associated with just cooling that outside air. I'll call it Q dot OA, and we'll do that as a m dot delta H as a starting point. But what is M? Mass flow rate. We're probably more apt to work in volume flow rates. So mass is density times volume. So density times volume flow rate times delta H. And since the psychrometric chart has specific volume instead of density, we'll change this to volume flow rate delta H over little v, specific volume, and we'll make our substitutions into that. So the CFM, volume flow rate, is 3,000. I'll write out the units now, feet cubed per minute, and we're going to need to convert to hours since we want BTUs per hour, so 60 minutes per hour, and this is why I'm writing out the units, because that is easy to miss. And then the delta H, 33.9 minus 28.2, and that's BTU per pound. That's all being divided by the specific volume, 14.1 cubic feet per pound. And if you're wondering where all these numbers are coming from, they come from the psychrometric chart. When in doubt and you're looking up the specific volume, a question I often get is, should that be for the air that's in the room or for the air outside? The rule of thumb is to use the incoming air. So if it's going from A to B, use the specific volume at state A. In general, the density doesn't vary too much, so if you just take the average between the two, 9 times out of 10 you'll get away with it. So let's cancel out some units. Minutes go away, cubic feet go away, pounds go away, and we should end up with BTU per hour, and then we'll do the math on it. So Q dot OA works out to 72,800 BTUs per hour. So the total capacity of the air conditioner, which is the question we've been asked to answer, is going to be the cooling of that outside air that we just calculated and the total heat load from all the internal sources, people, and external sources which were given. That's that 298. So we got to add that as well. So this was our Q total, excluding the outside air. And that is truly what the unit is going to have to keep up with. So those two taken together is a grand total of 371,600 BTUs per hour, which we can turn into refrigeration tons, divide by 12,000 BTU per hour per ton. That works out to 31 tons. So now we have 3 of 4 answers.